Good day, my students and viewers. I'm Mr. John Paulo F. Baribar, your science learning partner. Let us make each science classes be filled with saya. For this session, we are going to tackle our Week 3, Module 1, First Quarter lesson. And I would like you to prepare yourselves by opening your modules entitled Plate Tectonics on the Go. For this session, we are going to tackle plate tectonics theory. And here are the objectives of our lesson. First, explain plate tectonics theory. Second, identify and describe the types of plate boundaries. Third, relate the distribution of geologic features such as earthquake epicenters, volcanic eruptions, and mountain ranges in plate tectonic theory. And fourth, present a plan for community on how to mitigate or reduce the effects of disaster-related activities or events such as earthquakes, tsunamis, and volcanic eruptions. And so before we start our present lesson, let us have first a review. So for our review, I would like you to arrange the following phrases to form a complete thought or a sentence. And I will be giving you 1 minute to finish this. And your timer starts now. Last 10 seconds. Time's up! And the correct answer is triangulation method is used to determine the earthquake epicenter using a distance information from 3 seismic stations. Our planet Earth is amazingly beautiful. Based on what we have learned from our previous lesson, there are different geologic features that makes our planet so beautiful. Such geologic features consist of mountain ranges, our mountains underwater or ocean ridges, and as well as our volcanoes. And the creation of these wonders or geologic features is explained by a theory. And that theory is the plate tectonics theory. So our lesson for today will be tackling about this theory and all of the important information and concepts that revolves around it. Are you ready now to listen for our discussion? If yes, let's start. Concept number 1, plate tectonics theory. Plate tectonics theory is the product of hypotheses made by 3 scientists last 1960s. And these scientists are, first, Tuzo Wilson. He introduced the term plate for the broken pieces of the Earth's lithosphere. Second, we have Jason Morgan. He first identified the 12 moving plates that move relative to each other. And thirdly, we have Xavier Lepichon. He published the location of plate boundaries and direction of its movement. All of these 3 scientists that contributed on our plate tectonics theory are all geologists. And because of their studies, the geological movement on their time really agrees on their hypothesis. That's what makes their hypothesis a theory. Based on the plate tectonics theory, the pieces of the Earth's lithosphere are in constant motion driven by convection currents in the mantle. As what you can see on our picture, here lies the island or the landmass of Iceland. Iceland is in between two moving plates, and those two moving plates are the North American plate and Eurasian plate. In this theory, the plate moves slowly in different locations or directions, and this causes geologic events or features such as earthquakes, volcanic eruption, mountain building, and etc. So let us now move on what convection current is. Convection currents or cells makes the plate move. The convection currents in the mantle move the plates as the core hits the slowly flowing asthenosphere or the elastic or the plastic-like part of the mantle. Because of the asthenosphere's plasticity or elasticity, the materials from it goes into a circular direction due to temperature changes. As the material heats up, it goes up, and then when it cools down, it goes down and follows these circular directions that now contributes to the movement of the layer found in the upper part of it, which is the lithosphere. So let us review concept number 1, plate tectonics theory. Plate tectonics theory explains that pieces of Earth's lithosphere are in constant motion, driven by convection currents in the mantle, and convection currents or cells makes the plates move. Concept number 2, plate boundary types. Plate boundary is where edges of the Earth's plates meet. And plate boundaries are extended in the deepest part of the Earth's lithosphere. So it is not only found in the surface, but also lies on the deepest part of the lithosphere. We have 3 types of plate boundaries, and these are: first, divergent plate boundary; second, convergent plate boundary; and third, transformed plate boundary. And they are classified based on the movement or the action of the plates, as what you can see in the illustration at the left. Let's go to the first type, the divergent plate boundary. In divergent plate boundary, 2 plates move apart to one another. As what you can see in the illustration, one part of the plate goes to the left and another one goes to the right. And we call that moving apart as rifting. When rocks are pulled in divergent plate boundary, the rocks get thinner, cause stress called as tension. So what is the byproduct, or what would be the effect of having divergent plate boundary? First, we have seafloor spreading. Seafloor spreading is the spreading away of the oceanic crust forming ridges or mountains on the ocean. And in these ridges, or some of these ridges, can cause the ejection of material from the interior of the earth, or what we call the formation of volcanoes in the ocean. Second one is the formation of rift valley. When we say rift valley, this is the creation of valleys on the continental crust. So the illustration at the right helps us to know the movement of the plates in seafloor spreading as well as in rift valley formation. Next, we have convergent plate boundary. As what you can see in the illustration, the two plates, the plates in the left and the right, converge to one another. In this type of plate boundary, two plates collide together or they move towards each other, or what we call as the collision process. And when rocks are pushed in convergent plate boundary, the stress is called compression. Just like when you're going to take two pieces of bread and we move them towards each other, the two breads can compact one another or they can be compressed. There are several types of convergent plate boundary, and these several types can cause different products. Okay? So, the different types of convergent plate boundary depends on the type of crust that can collide with one another, making these different products. And what are those? So first, we have oceanic continental convergence. Second, we have the oceanic convergence. And the third, we have the continental convergence. So let us take each type one by one. So let us have the type 1, which is the oceanic continental convergence. So from our previous lesson, we have tackled the different types of crust, right? And we have the oceanic crust and continental crust. So for type 1, oceanic continental convergence, this is what happens. The oceanic plate is colliding with the less dense continental plate, thus producing an area which subduct, or what we call the subduction zone. When you say subduct, it goes down because of the changes or difference in density. Subduction zone is the process by which oceanic crust sinks beneath a deep ocean trench and back into the mantle at the convergent plate boundary. And as what you can see, this type of convergent plate boundary makes up volcanic arc, or what we call a series of mountain volcanoes, illustrated in our picture. So for you to be able to understand well how subduction zones produces volcanoes, here is a clear illustration. So as what you can see, when two plates converge, okay, it then produces one plate to subduct or goes down because of its density. So when there is density difference, so what happens to the material that is being impacted is that it goes upwards due to the forces that hits on this part, and the material that goes upwards then now make a volcano. So let's move on to the next. So here is an example of volcanic arch. So we have series of mountains in South America known as the Andes Mountain. And Andes Mountains are one of the active part of the planet Earth that produces volcanic eruptions. Next, let us move to the second type. The next type is what we call the oceanic convergence. In oceanic convergence, the oceanic plate collides with another oceanic plate. So here it goes, the less dense plate slides under the more dense plates, creating a subduction zone called a trench. So because of this type of convergence, okay, it now makes an volcanic arc or a series of island volcanoes illustrated on our picture. So let us have the example of it. So one of the example of it is the island arc, okay, found in the Japan. More likely, the islands in the southern tip of Japan are all volcanic islands. So meaning, these are areas where two oceanic crust meets, making now series of volcanoes. So let us now move on to the third type of convergent plate boundary. And we called it as the continental convergence. In continental convergence, a continental plate collides with another continental plate, and this develops collision zones between continental plates or the place where folded and truss-faulted mountains form. So this type of convergent plate boundary makes mountain ranges. So here is an example of continental convergence. So we have the mountain ranges in our country, specifically in Luzon, or the Sierra Madre mountain ranges. The Sierra mountain ranges is found located from the southern part of Cagayan province to Quezon province. So let us now move on to the third type of plate boundary. So we have the transform plate boundary. As you can see in the picture, in transform plate boundary, the two plates move past each other in opposite direction. In this type of plate, rock is pushed in two opposite direction or sideways, but no rock is lost, and we call the stress as shearing. So an example of transform plate boundary is the San Andreas Fault in California, which is the world's largest active fault. So the transform plate boundaries are where Earth's powerful earthquakes are developed. So let us review the concept number 2, plate boundary types. So the three types of plate boundaries are: first, divergent plate boundary; second, convergent plate boundary; and third, transform plate boundary. So the action of divergent plate boundary is moving apart. In convergent, they collide together, and in transform plate boundary, they move past each other. Tension stress is what is found in divergent plate boundary. Compression is the stress called in convergent plate boundary, and shearing is the stress called in a transform plate boundary. Divergent plate boundary creates rift valleys and seafloor spreading. Convergent plate boundary creates either island arc, volcanic arc, and mountain ranges. And transform plate boundaries are earthquake zones. For concept number 3, the disaster risk reduction related to geologic events in the plate tectonics theory. So let us have first the meaning of disaster risk reduction. According to United Nations International Strategy for Risk Reduction, disaster risk reduction or DRR aims to reduce the damage caused by natural hazards like earthquakes, floods, droughts, and cyclones through an ethic of preventions. So here are the keywords that we can relate to disaster risk reductions. So the keywords are prevention, recovery, exposure, mitigation, preparedness, hazard, vulnerability, resilience, critical infrastructure, risk transfer, capacity, early warning system, and others. So based on our lessons, we have different disasters or natural hazards that can be related on our lesson in plate tectonics theory. And these disasters are the following. First, the occurrences of earthquakes. Second, the occurrences of volcanic eruption. And third, the occurrences of tsunamis. All of these natural hazards has been studied on the previous grade levels. And we all know that we are not new to this because in the Philippines, all of these events actually happens. Just like what we have on the series of earthquakes that we have on the previous weeks, the volcanic eruption that happens in Taal Volcano last January 2020, and some minor tsunamis that happens on the coastal areas around our country. So for disaster risk reduction related for earthquakes, the PVOCS or the Philippines Institute for Volcanology and Seismology has instructed us or has given us different ways on how to mitigate the effects of coming earthquakes. And we all know that we cannot know when and where an earthquake will happen. So here are the things that we need to consider. So on our previous lesson on grade 8, your teacher or your science teacher has told you to drop, cover, and hold when there is an earthquake, and then when the earthquake is done. So all you need to do is to look for a safe place for you can settle with and be able to track what will happen next after this major earthquake. In our schools, before the pandemic, we are doing our monthly earthquake simulations. And this earthquake simulation has told us to do what are the correct practices on vacating or evacuating our school or our classroom or different areas in our school during the occurrences of earthquakes. Next, some earthquakes may cause tsunamis. So, the PVOCS also issues tsunami alert levels for the areas wherein there is or for those areas that are near coastal waters. And just like during earthquake when we have drop, cover, and hold, so during the events just like having local tsunamis, you need to observe 3 important signs for you to be able to know when there is a tsunami on your location. First, there is a great shaking caused by an earthquake, and then there is a drop in the height of the water in the ocean, and then a roar or an astounding sound may occur after this drop in water level. Third, during volcanic eruptions, there are many certain events that may happen. First one is that there will be some ashfall. And we all know that volcanic ash is very bad for our health. That is the reason why DOH, as well in cooperation with DOST, has produced pamphlets or information sheets regarding the bad effects of ashfall, specifically in our respiration. Also, the PWOX again has been issuing volcano alert levels for us to be able to vacate different individuals that are located in the permanent danger area zones, or the permanent danger zones rather. So, as what you have in our experience here in Metro Manila, during or rather after the eruption of Taal volcano, we are instructed by the Department of Health to wear N95 mask. So for concept number 3, or disaster risk reduction related to geologic events in the plate tectonics theory. Disaster risk reduction, or DRR, aims to reduce the damage caused by natural hazards. And disasters related to plate tectonic theory are earthquakes, volcanic eruptions, and tsunamis. And that ends our discussion for this session. And before we end up, let us do an activity. So your task is to have a go bag selfie. So what is a go bag? A go bag is an emergency preparedness kit that will help you survive a disaster for almost a week. So this grab and go bag will be used in times of disasters or calamity. And these are the basic contents of our go bag. First, it should contain your personal information. And also, the information is well supported by the important paper documents that you have at home. Next, it should contain food that never expires so fast. And you should remember that the food should be always ready to eat. Next, you need to place there your 1-week medication when you have pre-existing illnesses. Next, you need to have your first aid kit or medical supplies inside your bags so that you will have something to use when there are emergency situations. Next, you should have your concrete amount or supply of water for about 3 days to 7 days. And what is suggested type of water for this is a distilled type, so that the water will never become stale. Next, you should have clean clothes also on your go bags. And during times of calamities or disasters, the electricity and also our power supplies can be cut, or even our telecommunication lines. So it is important that you have your radio or transmitters with you, together with batteries and even flashlights, so that it can be used for searching your loved ones during times of disasters. And one of the important things to consider is that you should have your family evacuation plan. So what is family evacuation plan? The family evacuation plan will help or will teach all of the members of your household to locate a certain area where you can evacuate when there are times of calamities or crises. So for instance, your parents are working somewhere in Quezon City and you're studying here in Caloocan. And for example, your sister is studying in Manila. So you need to choose a common area where you can meet all together in these trying or difficult times during disaster or crisis. So, do you now understand what a go bag is? So I want you to have your selfies with you with your go bags and comment down your selfies on the section for our performance task in our science page. So I would like to remind each and every one of you that this activity is one of your performance tasks this first grading period. Is it clear? So if it is that clear, so let us now move on to our last section of this video lesson. Here are the 3 important things you must remember. First, plate tectonics theory explains that pieces of Earth's lithosphere are in constant motion driven by convection currents in the mantle. Convection currents or cells makes the plates move. Second, there are 3 types of plate boundaries: the divergent plate boundary, convergent plate boundary, and transform plate boundary. Third, disaster risk reduction or DRR aims to reduce the damage caused by natural hazards. Disasters related to plate tectonic theory are earthquakes, volcanic eruptions, and tsunamis. We are in the latter part of this video lesson, and before we end this up, let us check your understanding. For today's checking, we will be having a true or false test. So please prepare your pen and paper. You need to write true if the statement is correct and write false if the statement is wrong. I will be giving you 10 seconds to answer each item. Are you prepared now? So let's begin. Number 1. The distribution of volcanoes, earthquake epicenters, and mountain ranges are distributed in close along the borders of tectonic plates. And your timer starts now. The correct answer is true. Second item. Mountain belts are produced when plates slide or grind past each other without diverging or converging. And your timer starts now. And the correct answer is false. Next one. Earthquake epicenters are found everywhere when there is a border between tectonic plates. And your timer starts now. Correct! The answer is true. Next, educating the community on what to do before, during, and after a disaster will help mitigate its effects in some hazardous area. And your timer starts now. Correct! The answer is true, and it is under DRR or Disaster Risk Reduction. And finally, volcanoes and earthquake epicenters are found far from plate boundaries. Your timer starts now. Yes, the statement is false because we all know that these two geologic features are in close contact with plate boundaries. So what you're going to do with your scores? So when you have 4 to 5 points, you need to move to the next lesson. You have 2 to 3 points, you need to check your misconceptions or wrongly answered items. And that ends our session for today. And I would like to thank all of you for watching this video. Kindly subscribe to me to my YouTube channel, John Paulo Baribar. Or you can reach me on my Facebook profile name, Baribar John Paulo. Here are my reference or guide for making this video. This video is for educational purposes only. So till next time, students, bye-bye!